Hey there, I'm Caden Pierce, the Executive Director of the H20 Smart Glasses community, and welcome to our fourth Smart Glasses Meetup. You can see it's just me in the chat right now because we failed to start recording at the very beginning. We started a few minutes in, and so I'm just going to give a quick intro to this video for the recording afterwards. So to give a quick intro to the H20 Smart Glasses community, we're focused and dedicated to increasing the consumer adoption of smart glasses by connecting users to industry and helping industry understand what users want, and by connecting industry to users and to help industry to understand what users want on one side, but also to allow the industry to communicate to users what types of use cases that are available to them that they can use today. So we're excited to have everybody here to join the event. As soon as it switches over, you'll see there's many people joining and multiple presentations. So we have a simple schedule, a couple presentations, Q&A, and then an open discussion. And I wanted to briefly start by pointing out how exciting things are right now. I think joining the H20 Smart Glasses community right now is like joining a smartphone community in 2006. We're just on the cusp of mobile phones getting to a technological point where they're ready for consumer adoption. We kind of know what that looks like. We know a lot of the use cases, and we just need to get the technology and the devices there in terms of weight and physical comfort, social comfort, visual comfort for people to adopt. So I recently went to CES and I saw a whole bunch of demos and glasses that are about to drop that are either right just at the point where they're ready for consumer adoption, or there may be one generation prior to consumer adoption. We're talking about places like TCL, Vuzix, Oppo, Nreal, Inmo, and others that are going to be bringing out glasses very soon. So with that said, we're going to start with our presentations. For our presentations, we have Xavier Bonjour from ActiveLook, and they're building light AR glasses. We have Phuoc Trinh from SoundxVision, building smart glasses gesture control devices. So Xavier Bonjour is the marketing and partnerships director at ActiveLook. And ActiveLook is developing light AR glasses, which features incredibly small size, low weight, and low power displays and electronics, while they're maintaining high brightness and a good visual experience. Now they have the Engo product line, which is directly available to consumers that focus on fitness and health and wellness use cases. And MicroLED, the parent company, Micro OLED, to be clear, is developing one of the world's smallest and lowest power near-eye displays. And so with that, I'm going to welcome Xavier Bonjour, and we'll start about 30 seconds into his presentation. Enjoy.
Today I want to talk about the concept we are pushing forward with the ActiveLook technology, which is the light augmented reality. Then I will explain why low power is key to access this light augmented reality market, and then a quick overview of what we do, the ActiveLook technology, and why we do it this way. So I guess, Caden, how much time do I have?
Ish. However much you need, but 5 minutes, 12 minutes.
Good. Okay, I'll try to be below, around 5-6 minutes then.
Hey, if you need 10, take 10.
No, that's all right. I think the key message is we don't need. I think it's more interesting to go into the Q&A. So let me see. Sharing the screen. Say yes. So that's okay. You see the screen?
Yep.
Okay, good. So light augmented reality. When you look at augmented reality, we all agree that physics is difficult. For augmented reality, and that's why we see that the market of smart glasses or augmented reality in general is broken in, or is split into three segments, we believe. One is this advanced augmented reality, which is related to metaverse, and yeah, many people are talking a lot about this technology, and you have the big names of the big tech companies working there. That's when you want to typically when you do SLAM, when you have you mix video and reality. And then we have a segment which we call it's called basic AR. We call it basic AR, and that's typically trying to put a mobile phone in glasses and all the features of a mobile phone, but within the form factor of glasses. And here, you know the usual suspects. And then we believe there is another segment which we call light AR, where basically you have normal glasses and you try to provide as much as possible, as many features as possible related to augmented reality. A couple of examples. There is what we do here. Also, I believe that what Ray-Ban and Facebook do fall into this category. So here the rule of engagement for this light augmented reality segment is the weight of the glasses. It needs to be below 40 grams. And there is quite a rationale for that. Is if you want to wear the glasses for more than a few hours, it needs to be very light. If you want to move around with glasses, it needs to be even lighter. So weight is clearly a limit. There is the autonomy. Like for smartwatches, we believe the autonomy should be around between 12 to 24 hours. I think in reality that should be about 18 hours, which is the day where the time of the day where we don't sleep. And then we should not forget that glasses, it's a fashion item. So glasses need to look good, otherwise people won't wear them. So we believe these are the three basic rules we cannot bend. So I'm going to skip that. I was playing this morning with the ChatGPT. Basically, it says, when you ask ChatGPT about the same questions, they have similar answers. So the big issue behind the weight is actually power consumption. When you look at the to achieve these 40 grams, typically you need to have very, very low power. On the right hand side, we plotted the weight of the glasses with respect to the power consumption with our own architecture. And I guess for other system architecture, it will be pretty similar. You see that if you have the 20 milliwatts, which we have, we can reach the limit of 40 grams. But as soon as you put a bit more power in the system, and usually it's in the display, or if you want to add a camera or all the things, then you go beyond the 40 gram limits, and you are very quickly in the 50, 60 gram limit. And then, of course, if you go into even more power consumption, then the weight increase. So here, typically, it's if we want to use a laser-based system in smart glasses, it's very difficult to get below 70 gram. So if we take these low power consumption limits, then that means you need to be very cautious about the power consumption. You need to minimize the computation that happens on the glasses because you need to stay in the 5 to 10 milliwatt limits. You need to minimize the radio traffic between the glasses and any other device because that can be pretty power consuming. And you need to minimize the display power consumption. So key message here is if you want to design or to play in the light augmented reality segment, you need to be very cautious about the power consumption. And and that's going to be probably my last slide. I want to explain how we basically what's the features of the ActiveLook technology, which we propose to the eyewear manufacturer, and how we solve these low power consumption issues. So I think there are two basic technology bricks which enable us to be very low power. One is, of course, we are a display manufacturer, so we've designed a display dedicated to this use case. So first of all, it's monochrome, but also it's a memory display, so you don't need to refresh the display, and therefore that means you don't need to spend energy in scanning rows and columns, and so that's kind of the secret sauce behind the low power consumption of the display. The other technology brick is actually we've shifted the computation power from the glasses to an external device. So we consider that light augmented reality glasses should be a companion device to another smarter device, whether it's a watch or a smartphone or any other computer. We think that's the best way, at least as of today, with the current state of physics and technology. That's definitely the best way to achieve this low power consumption. And of course, we designed an API and a specific protocol to minimize this power consumption and to minimize the data transfer between the application and the glasses. And then, maybe a few words on the business model we have in mind to explain this open and free API. What we want to do is to use to sell the technology to the eyewear industry, which we currently do. Actually, we do have customers, and we are growing this customer base. But the idea is to do powered by ActiveLook, which is the notion of ingredient branding or ingredient technology, if you will. And a little bit like Intel Inside, instead of having CPUs and PCs, then you have augmented reality engine and glasses and eyewear brands. So these are our customers, and we are developing an ecosystem of partner applications which can use the API to address the display and provide content to the glasses. So I guess I'm gonna stop for now. I could go into the detail of the technology.
Xavier, maybe if in the last 30 seconds you could just mention the use case you're focused on.
Use case. Good point. Use case. We focus on anything which is either notification or mission critical information. So currently we've started to address the market segment of sports. So instead of having your sports data on the watch or on the bike computer or anywhere else, then you have it directly in the glasses, and that's clearly a very good use case. We have more and more athletes using these glasses to train, for coaching, for competition as well. It really helps the motivation. So sports is clearly a use case. Related to sports, in the outdoor world, there is navigation as well that we have identified as a key use case for this type of glasses. So let's put it outdoor, sports, consumer electronic, outdoor. Then we do have many use case for the I would call it government forces, whether they are the military or first responders. They do have a lot of interest, and we have started several programs with governmental organizations to develop this technology into specifically for them. And we have started to address the industry segment. And here it's a bit of a funny story. So the typical use case is an operator in the factory or wherever he works. Very often he needs to have information coming from another equipment. So the display, which is on a remote equipment, it's very handy to have the information in your field of view. Or when you do something, you need information and you do something with your hands. And we saw we had many requests, people buying our sunglasses, and clearly these guys buying the glasses, it was not for doing sports. It was equipment manufacturers or factories, and we realized that these people, they were buying sunglasses to wear indoors because they would need to. Yeah, they thought it was really helpful to use this head-up display, and that's why we released a few months ago what we call an enterprise model, which is very similar technology, but with the lenses which are not tinted, which are clear, so that you can use them indoor. So yeah, I guess that goes for the case. And
Excellent. Yeah, thank you very much, Xavier. Very, very interesting. I actually have just recently gotten a pair that I'm getting set up, so I'm very excited to get trying those out in the real world. And yeah, please note your questions and save them because we'll have a Q&A after our next presentation. So next up, we have Phuoc Trinh. He describes himself as somebody with a belief that seamless interactions will help promote AR and VR developments. And Phuoc's the founder and CEO at SoundxVision. They're dedicated to creating optimal interaction solutions for augmented reality, extended reality in general. And specifically, they're creating a thumb-based gesture controller to control all kinds of XR devices naturally. So Phuoc's going to tell us about the hardware that they're building and how that can control smart glasses. So take it away.
Okay, I will see my screen. Can you see my screen now?
Yeah.
Okay, I think I'm in the last slide. Okay, so hi everyone, I'm Phuoc and thank Xavier for a very insightful presentation on ActiveLook and their technology. We are SoundxVision. We are working on interfaces and input device to achieve effortless interaction in XR. So first, let's talk about our interfaces, what we are doing. I think we are all familiar with the concept of swiping and sliding when we are using the smartphone. Actually, if you imagine this, most of the time when we interact with our smartphone, it's either swiping this way or sliding. And those kind of interaction is very intuitive. And we believe that this kind of interaction can also be used to control XR device, for example, smart glasses, AR glasses, or even currently we are working with Oculus Quest 2 and Quest Pro, and everything is much more seamless than using the hand checking alone. And as you can see on my screen, we divide this kind of interaction into two main categories: swiping, horizontal, and vertical. And of course, we also have the fine tuning that you can do the swiping in very, very high resolution. For example, when you adjusting a volume of your headphone, or adjusting the size of the brushes that you use to draw in drawing application in AR. And on top of that, we also do all the kind of micro interaction. For example, when you start pressing like this, it's very, very difficult for camera to detect that kind of interaction because first, it happens very quickly, and second, it doesn't show very clearly on the camera compared to normally we do pinching to do this kind of interaction at the moment. I think like more of the time we do pinching or like touching the finger on some panel, augmented element panel that show in front of us, and then I think like let's see some of our demo. So for example, here is one example of a micro interaction. Like use the micro interaction that I told you about pressing to control a kind of like bullet or gun. It's kind of small game. As you can see, with our device, user can switch between multiple kind of like weapon and multiple modes of like shooting a bullet, as you can see. And for handshaking alone, it's either very time consuming to do this kind of interaction, or like sometimes it cannot even do that. And with our device, that's impossible. And then to add to the another dimension to the interaction, we provide this is our first input device, like is currently is prototype, but it have the force sensing mechanism that you can see. I can control my drawing just by like pressing hard or slow on my thumb and my finger, and even more like using swiping. You can also change the color of the brushes. I think like it's very quick and very intuitive for the user. And this is the demo that we do with the Oculus Quest 2. But right now we are working with the Quest Pro for color pass-through, but the idea is still the same. So, okay, I have talked, like introduced my interfaces. Now let's get into the hardware. This first device that we developed is the input exploration kit. And the idea of the device is to improve the handshaking, as I mentioned earlier. And this device focuses more on the professional sizes of XR in general. So it has the 2048 level of pressure. It's just like the stylus you use when you draw, for example, Apple Pencil or some kind of Wacom that I think like some of you might be familiar with. And next thing, like to achieve the like this kind of device working on top of a handshaking system and improve it. So naturally, it have 6 degrees of freedom by default. But we are working on sensor fusion, which means like we only use the camera for correcting the drifting of the IMU. So that means we can lower the power consumption of the class itself using that approach. But like we are still early on this road, and IMU are not that like easy to deal with. So it's gonna take a little bit time to like have a complete finished policies algorithm for this kind of thing. But like it's very promising. Seeing we all know that camera consume a lot of computing power, and if we can somehow reduce this, can also like reduce the battery requirement for the smart glasses, and I think that's a very, very critical aspect. And this kind of device run on Bluetooth Low Energy, which consume very, very little power. With this kind of device, currently I can run about 3 hours, but like we are working on optimization with the goal is to have it, for example, like 8 hours of using, continuous using. And maybe it's going to happen with our next iteration. And we are at the same time, we are also working on the software development kit for Oculus using Unity. And maybe like currently I don't see that much demand for Unreal Engine, but maybe in the future we also integrate this solution to Unreal Engine. And the idea of this device is for smart classes manufacturer to implement the input device into their system. For example, like some industrial device or something like that. And this device currently like focus on professional. So it's lack of one idea, one of the idea that I believe that's very critical, because like wearing this outside it doesn't look that good, you know. So that's why we are working on this kind of thing. We call currently it doesn't have the official name yet, so we call it the ring. Actually, I have been wearing this. Can you see this on my webcam? So this is just like design mock-up that we are doing. Actually, we have so many of them right now, but I think like currently I'm testing the interference of this kind of device to my normal life, and I'm happy to say that I have wear it for more than a month or two, and I can wear it all day without any interference with my normal activities. And I think that this may be the way to go to the input device of outdoor smart classes, AR classes. And the difference between this kind of device and the input exploration kit I showed earlier, it doesn't have the pressure sensitivity sensing. Yes, we are working on that, but like it's gonna take quite a while. But we want to one day for the device to have the pressure sensitivity, because like that's a whole new dimension which can be very explorative for the AR in general. So, but by compromising the pressure sensing, we create a device that do the interaction contactless without the user contact with the sensor. Because like earlier, user need to interact with this piece of touch sensor that we attach here. But with this device, it works solely on inertial measurement units. Like actually, I can show you this. This is the working prototype. It's a little bit bigger now, but like this is the working one. The idea is like using the inertial measurement unit to recognize the swiping and sliding interaction, and the interface I showed you earlier will be consistent between the input exploration kit, home controller, and the ring. That means you will have swiping, sliding, and fine tuning. I believe that this might be the way we can move forward with the smart classes next generation. And I think that's it for my part about like input and interaction for XR and our vision. What should be done with the cloud device? So, if you have any question, I'm more than happy to answer them. Thank you.
Awesome. Thank you so much, Phuoc. That is really awesome. And I had not seen your ring concept and prototype yet. And actually, one of my first questions for the Q&A was going to be exactly about that. So it's very exciting to see you're working on something for all-day wearability. And yeah, with that, let's move straight into the Q&A. This is everybody's chance to ask any questions you want to either presenter. And feel free to just start speaking, unmute yourself and ask, or jump into the chat, or whatever you want. But please go ahead. Don't be shy. Who's got a question?
I think I can ask Xavier some question about interaction with your glasses. Like, for example, you have a API now to interact with your glasses, right? You are displaying the content from the API directly to your glasses.
Absolutely. It's described on GitHub. If you look for ActiveLook repository on GitHub, you'll find the API, the SDK, the demo app, and so on. The API has, you can send information, so basic graphical comments. I would say 1980 graphics type of content, but you can also receive what I would call interruption. There is a gesture sensor we have embedded in the glasses. So indeed, when you wave your hand in front of the glasses, that can be detected by the driving application, and then you
Okay,
can.
that's nice. Yeah, I was actually trying to merge the solution that SoundxVision have currently. So, for example, like a sports person wearing the glasses and riding, so basically he can see one display at a time, right? Just seeing in the
Yeah,
front that his speed and probably some other sports metrics.
yeah,
So what if SoundxVision's solution is merged with the gesture API, because we can actually have this kind of tap with
yeah.
the device, and it can maybe change the kind of sports metrics that the sports persons want.
Absolutely.
So
That makes a lot
so
of sense.
yeah, so I was thinking like Fuok and probably Caden, if you can also contribute like something about this knowledge of the idea. So I was pretty interested. Like I was when there was this announcement of this webinar, I was thinking like why not to talk in Q&A session about this thing. It's a very interesting thing.
So, comment on what you just said. I think interaction with the glasses, clearly that's a good idea. I think if there is a solution which can be combined with what we do, I think that's up to the, I would say, to the application designer or the application programmer to use both SDK clearly. Um, I, and I think that's probably a good solution, because with the glasses, what we don't want is when you wear glasses, touching glasses. It's not something you want to do, because especially when you are moving, if you run, you cannot touch your glasses. It's very uncomfortable, or it's sometimes painful, and because it moves, and it's very difficult. That's why we decided to go for a gesture, no contact type of interaction. It's very limited, of course, but yeah, that's what I can say
Yeah,
on.
and one thing, like as a biker, if I would have been riding a bike, I will concentrate more on holding my bike rather than like moving my hands always. So it's always like if the biker can just grip something and then move the fingers like with a micro interaction, it's obviously a good idea.
That's a good idea. Yeah. On the bike case, two things. Because the bike computer knows what you do. Think of it like a Waze, a pretty smart piece of software, where they can anticipate what you want to see, and you don't even have to interact with the glasses. They will show you what you want to see. So that's one way to solve the problem. And the other, on the bike, yeah, we are working more with mountain bikes or regular bicycle. They do have these little gear shifters or things you put on the handlebar, and it can be connected to the application to switch screen and control any application, and therefore whatever goes into the glasses.
Yeah,
Yeah, it does make a lot of sense
that's right.
that one thing that I think ActiveLook mentions in the material is, and I know this from running, is it's not fun to do this in the middle of your run. And so I mean that which I mean, I'm sure it's quick to just flash your hand in front of your face, but if you're trying to beat your 20-kilometer
Yeah,
record or something like that, it's much better to tap your fingers while you're maintaining cadence than wave.
yeah.
So I could definitely see that as better. One question, I was wondering, for SoundxVision, So I was first going to ask Fuak if, like, if you were looking at doing something that was not covering the tip of the finger, because I was a really, I've tried that, and I've imagined that doing so would kind of limit some amount of grasping. And then you showed, of course, you're working on this ring, which is really great. So I'm wondering, in terms of smart glasses interaction, what do you specifically think you might be able to do with it? Like, are you navigating menus and selecting apps, or maybe like browsing the web even and selecting? What do you think?
I think like for the first generation of smart glass, I mean the current generation, I think like without the 6 degree of freedom interaction that we are used to with VR headsets, then we are limited to, for example, swiping and sliding. That means like you can do navigating in the menu, but also like because by the nature of the in inertial measurement units, you can also do the cursor, like 3 degree of freedom that maybe in the Oculus Go or earlier generation of VR headset you have this. So without the camera, you can do the 3 degree of freedom and also the navigating within the menu. I mean, yeah.
Gotcha. And does anybody else have any questions for the presenters? I always have an endless list of them, so somebody else should jump in.
Okay.
All right. Well, one question for Xavier. I've noticed you guys have ActiveLook in general has put out a lot of information that I think other companies are not putting out. There's often very secretive approach, and I get hit with like, sorry, I'm not allowed to tell you that too often. But you guys, I just read your blog post / white paper a couple days ago about power usage, really putting out the hard numbers, showing these graphs and stuff. So why are you taking a different approach instead of hiding everything? You're giving away some of the secrets. Why do that?
Because I guess this is physics is brutal. It's known. There is no secret. We believe it's people are shy to talk about it, but everybody knows about these difficulties. I don't know if you noticed, but lately some big tech companies which decided to add a battery pack to their glasses, or maybe postpone the light AR smart glasses they had in mind, and it's. Everybody knows that. It's just, and all the big tech companies know about it. We just want to remind the other people, that the basic rules of physics. And power consumption is battery weight, and the more power consumption, the bigger the battery, the bigger the cover to hide and cover the battery, and in the end, doesn't add up. You need to. And there is a limit, and I don't know. I guess we don't. Of course, I think we make it obvious because that's to our advantage. We are very low power, but on the other hand, we also are one of the very few brands on the market with actual use case and actual customers and actual sales. And I think it's also, of course, it's to give a positive spin on what we do, but we also need to explain that to the rest of the community. Don't forget about these very basic rules of physics.
Yeah, that's a great answer, and I mean it's a kind of funny state because it's like I agree that we should all know this, but then we're constantly seeing companies put out their claim is they're trying for light AR. But then somehow in their organization, they don't actually make the trade-offs. They're not willing to make the trade-offs that have to be made. They say they want it to be light, and then they put an MPU and a camera and stereoscopic and all this fancy stuff. And so it seems like, although we do understand this physics problem, some executives aren't willing to accept it.
It seems, in the past 20 years, silicon has solved everything. And maybe they stay in this mindset that you can cram everything in, and then the Moore's law and the silicon is going to solve it. Well, that's not the case. That's not been the case for quite some time for the AR glasses, and the way it's going, it's going to stay. I mean, it's going to take a long time before you can put a camera in glasses, and especially and even basic and very good light engine like a laser-based system, it's not a candidate. It cannot be a candidate for smart glasses because it uses too much power. So either you need to work on other battery technology with much more dense energy density, but that's not in the foreseeable future, as far as I know.
Yep, makes sense. So,
you need to make choices.
Yeah, I agree. So next up, Enzo, please go ahead, and then Tamara, I'll read off your question after that. Go ahead, Enzo. Are you there, Enzo? I can't hear you, but I saw you said
Enzo is gone.
to ask a question. Your hand is up. Maybe his mic isn't working. Okay, Enzo, maybe work out your mic problem, and I'll read off this other question, and we'll come back to you as soon as he disappeared. We'll see what happens there. So Tamara asked a question, and then Amaris is up next. A question for Xavier. How do you feel about the glasses to provide notifications about dangerous situations in traffic for cyclists? Thinking about connected traffic, which might be a possibility in the future, do you know about currently ongoing projects? So dangerous situations in traffic for cyclists.
Yes, that's a very good use case. You have to be careful though, because you don't want to put too much information in the field of view of somebody who is moving. Whether you don't want to look at your mobile phone when you ride a motorbike, when you run, when you ride a bike, you need to be careful on the information you put in the field of view. It's not like sitting in the couch. Things are very different. But indeed, that's a very good use case. We are working on the smaller use case we know is when there is an approaching car from the back. There are radars which can detect the car and bringing the view or the feedback of the radar in the field of view. That's something we want to go, but then we need to work with companies like Garmin who do bicycle radars, or we need to work with a partner. But that's in principle, that's a very good use case. And as I said, we've identified the use case of the bike radar. And probably, and of course, any other type of immediate danger is good to bring back to the field of view in a head-up mode.
Great. Enzo is back. Go right ahead.
Yeah, hi. Can you hear me now?
Yes. Welcome.
So, hey, Ken, how are you?
Good. Is this Enzo Gia from Longan?
Yeah, that's Enzo Gia from Longan Visions.
All right, welcome.
Hey, Axel, how are you? I have questions, and just give you a quick introduction. We are also working on AR headset, but as I said, we are especially focused on first responders and especially firefighters. And as you said, that lightweight is a crucial problem, especially for first responders. We already have a lot of gears on their system, especially for firefighters. We have huge SCBA air apparatus tank. And again, I saw you guys also work on first responder sectors. And one thing we learned from first responder sector actually will be the battery. The battery is always going to be an issue, especially for us. It's like we need a fireproof battery, which is the lithium ions out of the pictures. You have to using lithium phosphate batteries, which is increasing a lot of weight. Another things we want to ask is actually regarding, I saw you guys also work on industrial applications. So I assume your glass also meet ANSI 87.1 safety impact that one? No? Okay. Yeah or no?
Real honest answer is we don't know. they're in polycarbonate, so they could pass the test, but we haven't taken the test. Currently, people who use the glasses, it's more for indoor environment with equipment in the medical environment. Or
Okay.
so, of course, we are looking at providing a model which would be compliant with this ANSI certification, and so we are actually taking the certification as we speak, and so I don't know the answer.
No, I see. Yeah, because currently we are for our like applications, instead of impact resistance, we also need to make it fireproof as well.
Yeah.
And just want to share kind of our findings, kind of.
No, what I can say is, as I said, we are working on the military programs, and these guys need, the it's not bulletproof, but it's ballistic certified, and I don't know about the fireproof certification, but yeah, we are working on models which would be compatible with the kind of use case you have in mind.
Yeah, I see. Thank you. And just follow up on that, I assume the display you have here is a single color display, right? On a reflect to the visor, a reflect not to the glass, right?
Yeah, it's a monochrome single color display, but we are working on a color display as well. I mean, yeah, we can do it, but we haven't done it yet. But yeah, it's in the pipeline.
Understood. Okay, I think yeah, and currently I think you guys still for the battery you guys focus on using lithium-ion batteries. Is that correct?
Yep, absolutely, yep.
Okay, great. I think maybe there's some collaboration opportunity in the first responder sectors, and maybe guys reach out after the meeting. Then I'll see. All right.
Okay, thanks.
Thank you.
Cool. Thanks, Enzo. And Aramis had a question.
I don't know. Can you all hear me?
Yeah, welcome.
Hey, thanks. I'm not sure it's much of a question. It's actually gonna. I'm running the risk of sounding very silly right now. But basically, I mean, I hear mention of batteries definitely an issue, right? Batteries add weight. Do you know, maybe anybody here know, if there's been any research done on sending like current just through the body instead, right? So that you don't need to worry so much about the weight. I think there's two ways that might be accomplished. One would be actually running, there's A, electrical tape, B, there's electrical fibers, or C, just actually having there's like kinesiology type of tape that's used that's really close to skin contact that really will just adhere to the skin, that might allow you to give you the battery capacity without having to add weight to your device. It's just a consideration. I'm not sure if any research has been done in that space or what.
Well, duly noted. It's interesting.
Yeah, I mean, I have a couple things about that. Like, on one hand, so one thing we've seen very recently coming out from Ixana is YR. So this is a new communications technology that a lot of people are getting excited about. I'm sure ActiveLook's probably talking to them already. But it's 100 times lower power than Bluetooth, 10 times lower power than UWB for communications. And so it is propagating the signal across the body with kind of some high frequencies. But as far as I have seen, there's never been any development of that in the power envelope that you would need to be able to run glasses. Like ActiveLook, I think it's 20 or 30 milliwatts they're talking about, which is incredibly low, but not the level that you'd be able to run a pair of glasses at. If we're just talking about across your body, the other idea that has been thrown around in terms of like maybe wear a necklace with wireless charging. And I've talked to PowerCast, who are some of the leaders in wireless charging recently. And we tried to figure out, how realistic that is. And with current technology, it's not realistic, again, to hit the power envelope. If you're if you're far away from the glasses, you're not anywhere. You're not even going to hit 5 milliwatts. And then on the side, I do see what you're saying in terms of like we could run something along the battery, and I think without question you could make that work because we can make tethered systems work. And this is basically just making the tether hug your body. But will you every morning apply conductive tape down the side of your body to your pocket and plug it into your pants? I don't think that is going to become adopted.
No, I would also agree. But a shirt with it built in is reasonable, right? Or clothing with built-in, material that could conduct is more reasonable. Not necessarily something that you would have to tape on, right? Like I think that is kind of crazy. But if your shirt, all of your fabrics had that, then I think that seems more reasonable. I mean, we know that there is conductive thread, for example.
Yeah, it's cool. I mean, I don't want to say full out no. I think there's definitely challenges because going from the shirt to your glasses, then you have a tether. People do not like that aesthetically or socially to having the tether. But potentially there's some way to make that work. It's an interesting idea.
Hayden?
Yep.
You mentioned I don't remember the name of the company which does the body radio.
YR from Ixana.
Oh, YR. Yeah, that's it. I think that's pretty good technology in itself, but one of the difficulty for a company like us is, for the type of technology, is we need to have a companion device. So we need to have the two devices equipped with the technology. Basically we need to have Apple, Android, until it's adopted by one of the big guys. It's going to be difficult for us to deploy this type of technology, even though the technology is very, very good, very impressive in its own right.
Yeah, I definitely know it's a big chicken and egg thing for these new communications technologies. One thing that they're doing to try to get around that is they make a phone case that plugs in with USB and it kind of gives you immediate. But I do know, trying to deploy to consumers, now they don't just have to get your glasses. Now they have to get a case, and you don't just have to get a case. You now have to use a new type of case for your specific phone that has a block of copper on it. So that's a challenge. I think if they can get a deal with a Google or a Samsung or something, it could really change things a lot. Frank, please go ahead.
Yeah, hi, good morning. I hope you can hear me. So I'm trying to figure out whether the ActiveLook glasses have a microphone. It doesn't seem so. I feel this could be very useful for interaction, right? So I wonder whether you're considering that maybe to put a microphone array into the glasses in a future generation.
I think so. The answer is no. We don't have a microphone. To the question whether we consider putting a mic in the next generation is. It's on the table. I think it all depends on the power consumption. So we need to look at. I need to. My batteries are running. Sorry. It's in the end it's a power consumption issue. So I guess. And not so much the mic, but the Bluetooth transmission between the glasses and the controlling device. Okay, so we are looking at it.
Okay, thank you. I mean, the one thing you could consider is only to send the audio stream after a gesture, maybe a touch gesture or something, until let's say the receiving device says, "Okay, I'm done" or something. Maybe that could cut the.
That could work, but what we can also do is to put AirPods when you run. The case we have today is glasses. If everybody, or even the military or the industry, they do have, if they want audio, they do have an existing audio system which they use. Like when you go running, you put your AirPods. Okay, so it's fine. So we haven't seen a screaming use case, screaming demand for audio as of today. Okay, so that's why we but it's a good point. I mean, the microphone is a good option.
Thank you.
Great. Well, in our last 2 minutes, I mean, this Q&A has been so good that we just kept going. If anyone has anything, if you have more questions, feel free. But also, usually we have open discussion at the end. So if there's anything you wanted to share or talk about or ask about in general, feel free. So does anybody want to share or have any more questions? Go ahead, Nam.
Oui, bonjour Xavier, ça va?
Bonjour.
Oui, bonjour, je suis le cofondateur de SoundxVision. Oui, je m'occupe tous les travaux liés au marketing de l'entreprise et je suis très heureux de vous rencontrer.
Okay, I guess we can switch in English for the benefit of.
Yes, of course, I think so. So actually, from my side, I don't actually have a question. I have more like an invitation, like because we already talked about how wonderful it's gonna be if we have a collaboration between your smart glass and our interaction solution, which is SoundxVision. So I'm really looking forward, like if we can. Getting to know each other better, or maybe having a collaboration between each other.
No problem. You can reach out on LinkedIn, or if you can, or send me a mail with my name on the contact at activelook.net, and yeah, we can find out some time to have a discussion for sure.
Perfect. Perfect.
Yeah, and I can because I have
true for
everyone's
everybody,
contacts,
by the way.
so I'll send out the contacts of our presenters and also Enzo and Nam. I can get you in an email group with Xavier after the call. So that brings us to the end of our fourth meetup, which was definitely very interesting and as fun as always. So a huge thank you, Xavier Fouac, for the presentations. Very interested to see what you're building. Super excited about both the light AR and the possibility of consumer adoption, and also SoundxVision's Ring controller for smart glasses and menu control and such. So thank you everybody for joining our fourth meetup. Please stay in the loop. Definitely join our mailing list on our website, smartglasses.community, and join the Discord. We're a very young community. We're just getting started, and there's already good engagement in our newsletter and on our Discord. So be sure to join. And yeah, with that concludes our meeting. So thank you very much, everybody.
Yeah, thank you very much, everybody, and thank you, Kaiden.
Thank you.
Thank you, Kaiden.
Thank you.
Bye-bye.
Bye-bye.
Yep.
Thanks,
Have
Kaiden.
a great day, everyone. Thanks, guys.
Talk to you soon.
Sounds good.